Okay, good morning, all of you. In today's session of class 10 physics, we are going to continue with light. Now, we were doing refraction up to this point, and starting from today, we are going to, we have been doing refraction, but starting from today, we are going to move on to lenses. Now, the thing is that a lens is basically uh, it is basically the boundary of a lens is two spherical surfaces. What happens is that there will be a glass sphere, this one. The center of the sphere is C1. There is another glass sphere, this one. The center of this sphere is C2. Now the overlap of these two spheres, this one which I have drawn as a solid with a solid marker, the overlap of these two spheres, this is called a lens. And the thing is that you will notice that this particular lens, it is very thick in the or broad in the middle, it is bulging in the middle, but at the top and at the bottom it is tapering. So at the middle it is bulging, but at the top and the bottom it is tapering. So such a lens is called a convex lens. So how do we define a convex lens? That it will, its boundary will have two spherical surfaces. So each spherical surface is part of a sphere. Like this spherical surface is part of this sphere, and this spherical surface is part of this sphere. And the center of this sphere is C1, the center of this sphere is C2, right? And this boundary portion is what we call the lens. And convex lens is defined like this, that it is thick in the middle and it is narrow or tapering at the top and the bottom. That is how we define a convex lens. Now, the other kind of lens is a concave lens. In a concave lens, what happens? That again there are two spheres. There are again two spheres. So you can see this is one sphere, this is another sphere. So again there are two spheres. The center of this sphere is C1, the center of this sphere is C2. And this time, okay, one important thing, we will follow a convention that everything related to the left sphere, okay, we will address it by the subscript 1. So I have written C1 because it is for the left sphere. I have written C2 because it is for the right sphere. Like here, C1 is the center of the left sphere, C2 is the center of the right sphere. So everything related to the left sphere, I will write it with the subscript 1. And everything related to the right sphere, I will write it with the subscript 2. And for your syllabus, it is assumed that the two spheres have the same radius. They don't need to have the same radius. It is not mandatory, it is not compulsory. But in your syllabus, we will assume that both the spheres will have the same radius. So basically, a convex lens is bulging in the middle and narrow at the top. Concave lens is the opposite. It is bulging at the top and bottom and narrow in the middle. So these are the two types of lenses, right? Okay, now what we will do is, now what we will do is, so I'll just draw one line like this, okay? And like I told you, this is C1 and this is C2. I'll draw one line like this in the middle. Now the line joining C1 and C2, that line is called the principal axis. Okay, the line joining C1 and C2, that line is called the principal axis. and similarly here also. The line joining C1, C2 is the principal axis, and I'll draw a line like this in the middle. Now, this line which I have drawn in the middle, okay, why did I draw this line? You see, we make a sweeping assumption about all lenses. This width is small, okay, this width is small, and the thickness, even when it is very thick, the thickness is very, very small. So we make two assumptions. One is aperture is small. Now what is aperture? Like I said, from top to bottom, that thickness is called aperture. So one assumption is that as aperture is small. The other is lens is thin. So these are the two assumptions for any lens. Aperture is small and lens is thin. So if the aperture is small and lens is thin, then instead of considering refraction from both the surfaces, we will only consider refraction on this dotted line, and that is very convenient. Otherwise, what you will have to do, you will have to consider refraction from both the left and the right surfaces, right? Let me just give you one example. Suppose a ray of light is coming like this. So then it will undergo refraction and then it will come out like this. So you can see that it is refracting inside and it is refracting and coming outside. So we are showing refraction at two places, the left surface and the right surface. But for convenience, we can skip that and we can just show refraction on this dotted line. Now interestingly, the way I have drawn the ray, it seems that it is crossing this point, the point of intersection of the principal axis and the point joining the top and bottom of the lens. So this point has got a name, this point of intersection, it is called optical center. Okay, it is called optical center, right? So this is C1, this is C2, and the line joining the top and bottom of the lens, it will cut the line joining C1, C2 at the optical center. So optical center is a very important point because if I don't show refraction at two places, if I show refraction only at one place, then it means that the ray will just go straight through. So this is a very good definition of optical center. Instead of giving a long definition like optical center is the center of the lens or optical center is the point of intersection of these two lines. So instead of giving such a long definition, we can just say it is that point on inside the lens at which no refraction takes place. That means if a ray strikes at optical center, it will go through. So that is the definition of optical center, right? Now, suppose a ray is parallel to the principal axis, a ray of light is parallel to the principal axis. So that ray of light after refraction, okay, it passes through F1, okay. So if a ray of light is parallel to the principal axis, that ray of light after refraction it passes through a point called F1. Now F1 is called the focus of the lens, and if I call optical center as O, then the distance OF1 is exactly half of the distance OC1, right? So that means you remember that C1 and C2 are the centers of the sphere from which we have carved out the lens. So OC1 can be taken as the radius of the sphere from which you have carved out the lens. By the way, it is called radius of curvature of the lens. So OC1 is radius of curvature. So OF1 is radius of curvature by 2, right? And one more thing is that just like there is a point F1 on the right, so there will be a point F2 on the left, and it will follow the same criteria. OF2 will be half of OC2, right? Now, if a ray of light passes through OF2, then after refraction, it will become parallel to the principal axis. So, if a ray of light is passing through F2, then after refraction, it will become parallel to the principal axis. So these are the three types of rays you have to remember. A ray passing through optical center will go straight through. A ray parallel to principal axis after refraction will pass through F1. A ray passing through F2 after refraction will become parallel to the principal axis. Now in case of concave lens, again if a ray passes through optical center, it will go straight through. Now this time you have to remember F2 will be here and F1 will be here, right? So I'll do one thing. I'll call the optical center ray as ray number 1. The ray parallel to principal axis, I'll call it ray number 2. And the ray passing through the F on the left, I'll call it number 3. So if a ray is parallel to the principal axis, right, then after refraction, it will, instead of what happens in case of a convex lens, that after refraction the ray tries to go closer to the principal axis. Right, this ray, it started going closer to the principal axis. This ray seems to be going far, but after refraction it straightened. So it's trying to go closer to the principal axis. In a concave lens, it goes away. So after refraction, it's going away. Okay, it's going away. But if you produce it back, it will come from F1. Right? If you produce it back, it will come from F1. So ray number 1, the optical center ray which I drew for this, that is this. Ray number 2, the ray parallel to principal axis, this is this. So how is ray number 2 of the first different from ray number 2 of the second? In the first one, ray number 2 after refraction passes through F1. That means it tries to go closer to the principal axis. In the second one, ray number 2 after refraction, it appears to be coming out of F1. So that is why convex lens is called converging and concave lens is called diverging. Because it appears that the concave lens is trying to send the ray away from the principal axis, diverging, and convex lens is trying to bring the ray closer to the principal axis. Okay. Now in today's session, I am just giving you only one homework. You will have to draw ray number 3. You will have to draw ray number 3 for concave lens. I haven't drawn it. That is your only homework. There is no homework today other than that. So I repeat again, your homework is you will have to draw ray number 3 for convex lens I have drawn, but for concave lens I have not drawn ray number 3. So you will have to draw ray number 3 for concave lens. That is your only homework. Okay. So very quick summary of whatever we have discussed till now. Today we are starting lenses. A lens is basically boundary of two spherical surfaces. Those two spherical surfaces are basically extracted from two glass spheres. So in this lens, the left spherical surface is extracted from a sphere whose center is at C1. The right spherical surface is extracted from a sphere whose center is C2. If you join C1 and C2, the line is called principal axis. If you join this top and bottom, then it will cut the principal axis at a point called optical center. What is the speciality of optical center? If a ray is going through optical center, it will not refract, it will just go straight through. So that is how we can define optical center. But for this definition to hold, there are two assumptions in lenses. The end-to-end width of the lens is small, aperture is small, and lens is thin. Actually, a ray parallel to principal axis after refraction goes through a point on the principal axis called F1. Now I didn't tell you that time, but this ray, in order that it should go to f1, for this also aperture small is necessary, because if the aperture is small, automatically this ray will go to the f1. If the aperture is not small, then this ray after coming out, like after refraction, it may not go to f1, it may go to some other place. So aperture small has got its own importance, and a ray passing through f2 after refraction will become parallel to the principal axis. So these are the 1, 2, 3 rays for a convex lens, and OF1 is half of OC1, which is equal to radius of curvature by 2, and OF2 is also half of OC2. And by the way, in your syllabus, OC1, OC2 both are same in every case situation. They don't have to be the same, but in your syllabus they are the same. So we will not even consider any other case. So OF2 equal to OC2 equal to R by 2. So it is called a converging lens because it seems to make the ray come closer to the principal axis after refraction. In case of a concave lens, the left surface center is C1, right surface center is C2. Join it, this is the principal axis. Join the midpoint of the top and bottom. This joining the midpoint of the top and bottom, you can call it the axis of the lens, like the vertical axis. And that is also optical center, this optical center. A ray passing through optical center will go straight through. So that is ray number 1, just like this was ray number 1. And a ray parallel to principal axis, it will diverge away, so it will never go to the principal axis. But if you retrace it, it will seem to be coming out of f1. So it is called a diverging lens because it tends to diverge the rays, whereas this one tends to converge the rays. And your homework is you will have to draw ray number 3 for convex I have drawn. You will have to draw ray number 3 for concave. So that is it for this session. And all the homework you have to submit by 9 PM on Thursday. Okay, I'll end the session. Bye all of you.